watch this. All right. So I could actually, oh, come on. Yeah, I could move 2 sine squared x to the left side. So I have 2 sine squared x plus cos 2x equals 1. Then I can subtract both sides by cos 2x, right? And then I can divide both sides by 2. So this right here is called a power reducing formula. Because what you're doing is you're reducing sine squared to another trig function that doesn't have an exponent, right? Or an exponent one. So you're reducing the power, right? This is sine squared. So it's really simple, right? All it is shift some things around. Just the algebra, right? Like, yeah, let's move that sine squared to the left side, and that's next to the right side, by 2. And it is, right? So if you see a sine squared, you can immediately do this, right? Just like in that problem I just showed you, you can immediately do that. And likewise here, I'll just kind of give it to you. I think you guys get the point. But if I move cosine squared x to the left side, and then this will be -1 minus cos 2x. You are correct. It's all negative. That was dumb what I just did. Thanks, Adi. Yeah, that's way more efficient, right? So cosine squared x, we 1 plus cos 2x. So these are not like some things that just fell out of the sky. Like, oh, here it is. It's just no, it comes from stuff that we've already derived. We derived double angle anyway from the sum of difference forms. The sum of difference forms, those are kind of weird. Those are more like, okay, well, I have to give those to you because they're a little tough to memorize. But once you have that, you can derive the rest from that, right? Like I could derive double angles from the sum of difference formulas. And then from the double angle formulas, I can get power reducing formulas by just doing some simple algebra. So that's what the power reducing formulas are. And if you want to do it for tangent, well, guess what? If I have it for sine squared and cosine squared, that's easy. Just do sine squared over cosine squared, right? Tangent squared x is that. So 1 minus cos 2x over 2. 1 plus cos 2x over 2. Flip the bottom fraction. What do you get? 1 minus cos 2x or 1 plus cos 2x. So that's how you derive them. They're pretty simple. So does that make sense how we got these? So we're good? Okay. Super easy. Fill in the blanks. Well, yeah. I mean, I know that's 2x. Oh, oops. My bad. My apologies. It's 4x. Ah, a little sneaky there. And that's going to be 6x. And that's going to be x. Do you guys see what I just did?
Yeah.
So you have to pay careful attention. It's super subtle, but very important. X, 2x, x, 2x, x, 2x, 2x. So that's 2x that goes to 4x. That's 3x that goes to 6x, 6x. That's x over 2, that's x. So on the other side, the angle's doubled on the left side. So just make sure you make a proper adjustment depending on what you see on the left side. Okay. So that just also gives you a little more flexibility. I mean, we can go through the motions if you want to see why it works, but just trust that it will work. So let's move on. Okay. We're okay? All right. Let's okay. Well, I just showed this one to you guys. So if you guys want to try it, just make sure you guys get it. I know I showed it to you. So you should be faster with this, I suppose. So that's going to be 1 minus cos 2x over 2. 1 minus cos 2x over 2. So it's 1 minus 2 cos 2x plus cosine squared 2x all over 4. Okay, I'm going to let you guys battle through the rest. Your job is to make the left side look like the right side. I mean, you probably could put a 1/4 for now. A -1/2 cos 2x. And a plus 1/4
cos squared 2x. Okay, now let's get out through the rest. Figure out what how the rest will look. And by the way, we do have power reducing formula for cosine squared 2x. You have power reducing formula for that also. Okay, I'm going to freeze my screen. All right. Clear. So, you guys should keep the 1/4 and they won't have cos 2x the same. You all done, Oliver?
Yeah.
Yeah, good. That's a good sign. Okay, boom. There we go. Got it. There we go.
So what I did, I took the last line just wrote, pushed up top, continue the problem, right? So these first two, leave them alone, they're fine, because we want that anyway, right? I mean, of course, not 1/3/8, but they'll take care of itself. But here, we did a power reducing formula like that, right? You got that, you got double A, so it's 4x. Then that's 1/2, 1/4 times 1/2 is 1/8. That's 1/4 times 1/2 cos 4x is 1/8 cos 4x. That's done. Half. Oh, sorry, 1/4, 1/8 is 3/8. Boom, 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 you're done.
So that is way better than what I showed you guys about a half hour ago, right? Yeah. So yeah, there we go. Okay, so we're done with that. Let's move on to part 4 of these notes. Come to think of it, I think we already done this. Have we done this already?
Yeah.
Yeah, I think we might be done. Hold on one sec. Wait one sec. What?
We have not done.
Yeah, I doubled the double identity. I doubled it up, guys. I repeated my efforts. Yeah, we've already done this. I think we're done. Hold on.
We haven't done half.
Yeah, I think I repeated these notes. I wasted paper. Yeah, because we've done that. We've done that. Half. Let's go to half thing. Yeah, I've done that. Yeah, I've done all the. Yeah, we've done all this. We used to power. Okay, so wow, I can't believe I did that. Okay, so let's jump. Okay, so let's jump to page 20, guys. Good. I feel much better about this now. Okay, so we totally could be done today. All right, let's go to half angle identities. Okay. So you can use the power reducing formula to derive the half angle identity. So we know, again, we know this to be true. That equals 1 minus cos 2x over 2, right? We know this. So if I change this to sine squared of x over 2, then what again this side?
But that's not sine squared.
Well, no, but if I change this angle, right? If I take half this angle, that better take half this angle. We just talked about that thing yesterday, right? But it's not sine. It's not sine x over 2, it's sine squared x over 2. So of course, what are you going to do? You're going to square both sides. And when you do that, what do you get? You get sine of x over 2 equals plus or minus root 1 minus cos x over 2. So that's where the half angle comes from. If you take the power reducing formula, you get power reducing formula. change the angle from x to x over 2, so that changes from cos to x to cos x. We already talked about that yet. And then square root both sides, put plus or minus, you're set.
And you could do a very similar derivation with cos x over 2 or tan x over 2. I won't do that in the interest of time. I think you trust it will work out just fine. But that's where it comes from, just so you know. Question on that derivation? No? Okay. And the formulas are all right there. And again, I'm going to give you the sum of difference formulas on our test, which will be on the 16th. I already put up in Schoology. But I'm not going to give you all the other stuff. The other stuff you could derive. So I'm not going to give you the other stuff. You guys are honor students. So here we go. How do I do this? That's going to be sine of pi over 8 equals plus or minus square root of 1 minus cosine of pi over 4 over 2. The plus or minus
Is there to kind of like cover all bases. You're not going to put plus or minus in your final answer because I know sine pi over 8 is positive, right? Because what quadrant is pi over 8?
Q1, right? So it's got to be positive. So the plus or minus is just there kind of to give you options. But I know it's just going to be positive. So it's going to be root 1 minus root 2 over 2 over 2. And I'm okay if you leave your answer like that. There's no need to do anything else. Leave your answer like that. I think most likely I'll make some multiple choice question to avoid any ambiguity of how to express your answers. So I think that's kind of fair. Leave as a multiple choice question. But you got to show your work. So let's do the next one here. Cosine of 7 pi over 12 equals plus or minus root. Now, what am I going to do? This plus cosine, by the way. So what will be inside this cosine now on the other side? Yeah, because you double it up, 7 pi over 6. And 7 pi over 12 is more than 1/2, right? More than half pi.
So what quadrant is that at? 2. 2. So it's going to be negative.
And so 7 pi over 6, that's negative half, right? No. Well, 7 pi over 6, no, it's a negative root 3 over 2, right? 7 pi over 6, am I correct saying that? Yeah. Yeah, okay. And again, you can leave your answer like that. And if you're ever unsure, and I'm still debating what will be non-calc and calc. I'll have to think about that over the weekend. But on your homework, at least, you could check. Well, I do put the solutions. Well, actually, no, I haven't written the solutions because I got to get that done. And we'll see if I get it done. But in your graphing calculator, right? Okay, computer's a little slow. Cosine. Ah, goodness. Cosine of 7 pi over 12. Make sure I'm in radian mode. I am. Okay, so something weird. Negative root parentheses 1 minus 0.5 root 3 and my parentheses. Gosh darn it. I'm checking my work, dude. That's right. No, Seahawks fans, they don't really pay attention. Okay. Niners are 4-0. I'm going to be talking a lot of crap. Just so you know. Sorry. I got into it. You know, Laura, Miss Grimmett, her son's a Cowboys fan, so we just started like having some banter.
That's fine.
Yeah. Okay, same thing. There we go. Yeah. That's right. I know your brother for a long time. I can talk to you. All right, so cool. All right, so it works, right? We know it works. Okay, let's keep moving. Okay, the rest of you guys are nice fans. We're all good. All right, let's move on. I think last page. Yeah, we're almost done. Good, excellent. All right, I'll do the first one, and I'll have you guys do part B. And we're going to do general solutions as well as solutions that lie in the first rotation of the unit circle without going counterclockwise. Okay, so here we go. 2 minus sine squared x. Yeah, just leave it like that, I suppose, for now. Actually, I take that back. Let's make that 1 minus cosine squared x. Because I suspect we're gonna have everything in terms of cosine anyway. And so 2 times so we're gonna power reducing, right? 1 plus cos x over 2. I think I did that right. Yes, I did. Because cosine squared x over 2 is 1 plus cos x over 2. Okay. Now, this is nice, right? Very nice, because the 2's cancel. If you combine like terms, you get 1 plus cosine squared x equals 1 plus cos x. Those cancel. Cos squared x minus cos x equals 0. Factor out cos x, 1 minus cos x. Cos x equals 0, or cos x equals 1. It's 0. And that's pi over 2 or 3 pi over 2. I did power reducing. I didn't have to use half angle here.
Wait.
I did power reducing, guys. And I don't think anything's extraneous. Yeah, I think we're fine. I think everything works itself out. Yeah, zeros, 1. Yeah, everything works itself out. And then generally, you could say it's 2k pi or pi over 2 plus k pi, where k is any integer. I think so. Yeah.
But you know, because that's for normal. That's for cosine.
And by the way, everyone check your work. Plug in the left side, plug the right side, so everything's matched. Or liberating on one side, it's fine next intercepts. Either way, you should be able to get this. And check your work. So that's my best friend. Check your work. Questions? Did I do anything wrong? So I can mess this up too. Yes.
Yeah, so I was trying to tell you, buddy.
No.
Yes.
Yeah, we'll get that.
What is
She wants to bring out her inner artist. Okay. So guys, let's do part B. It's finished strong. We're almost done. And then we get head start on homework. Okay, guys, let's do part B. I'll freeze my screen. We'll check our answers in 5 minutes or maybe less. Let's do part B. Last problem of the unit. And then we do review next week. I would do the cosine squared x. The reason why,
Because if you do cosine squared minus sine squared, you can stuck with the sine cube. You do 1 minus 2 sine squared x, you still have sine squared. If you do this, to make it simple, let's do 2 cosine squared x minus 1 to avoid that. To avoid any cubic trig functions.
I think it's very good.
Yeah, I got 0.
Oh, that's weird. You guys get cosine x equals plus or minus root 3 over 3?
Oh,
Wait, what? Hold on. What did I do wrong then?
Wait.
Would you just replace this?
Yeah, I guess that actually was zero.
Oh, wait, so here's the time.
Oh, I messed up, guys. Gosh darn it. Ah,
I get the one I go like.
okay, hold on.
Yeah, right there.
Wait, but this is like.
Yeah, I remember this.
Do you guys get 1/2 for cosine? Cosine x equals plus minus 1/2.
Yeah.
Hold on. What am I doing wrong here?
No.
Yeah, I'm not supposed to try to find out what they're doing.
Ah. Yeah, guys, I'm royally messing up. Give me a sec here.
Oh, yeah, because I'll sign it.
Oh, so you tell them if that's happening.
I've done it too.
You get sine x equals 0?
Yeah.
Yeah. I overcomplicate it.
0 and 5.
All right. Sorry, guys. I totally made some careless mistakes. Here we go. You get that?
Yeah, yeah. Yeah, I actually swapped these two. That's what I think for very good problems. And I just realized if I just put a negative out there, and there's 2 ways. Do a little variation of it, but anyway, it works.
Okay, cool. All right. So we get out at what time? 10:55 or 11 or? Okay, so we got about 12 minutes. We want to get head start with homework. Homework's shorter this time. It's just gonna be the rest of the packet. So 1 through 6, just 2 pages. Homework, yes, homework 16 handout, yes. Yeah, we got 55.